Please go away. Alrighty. We did something similar to this on last Wednesday, except I think we used float rather than int. Kind of tells you what it's doing over here if you scrolled over here. But why do you do this in this particular language? Why do you do something is equal to int g or something is equal to float g? What are the three data types we've talked about so far? Strings, integers, and floats. Right. Well, this function returns a string. And it has to be converted into a number before you can do anything useful to it. Because the language doesn't know what a string is. You may have typed in the word hello or Fred or whatever. You know, it's not a number until it knows it's a number. And it knows it's a number when it successfully passed through a conversion method, like a conversion function like that, which converts it into an int. And an int is a number, a whole number. No decimal points. Okay, so that converts it, puts it in a different variable named guess. In this language, you could just have reused the letter g and said g is equal to intg. That's typically what I do. And then if guess is equal to 5, that's an if statement. An if statement makes this code conditional. This code executes only if the if statement's clause here is true. So if the guess is equal to 5, it says you win. Else it says you lose. Game over. Now this is a pretty rough game. You know, you only get one chance at it. Fortunately, you know, once you get the number right, you'll get it right every time. So it's not really that fun of a game. So their descriptions over here. What does this do? Displays a welcome message, asks the user to input a guess, converts the input to a number. Was the guess number equal to 5? Tell the user you win. Otherwise, tell the user you lose and end the program. I don't know why they call that end the program. Tell the user that the program's over. So what are G and guess? Variables. Variables contain data in the computer's memory. They point to an address in the computer's memory. You could have thousands of variables in your program if you needed to. You know, these computers have billions of bytes in them, gigabytes. If you have thousands of variables, there's probably other ways of storing the data that's more efficient, ways known as lists or arrays that we will talk about. So a variable is just a label for data. It's a label that points to an address, and that address contains a value. So those are the three components of a variable, is its name, its type, and its value. So how do we run our code? Well, we type it in. Type it in with idle. So here we go. We're going to start idle. IDLE. And when you do that, if it does it, here we go, it comes open into the shell. If you try to write a program into the shell, it's probably not going to work, especially if you have to make any corrections. I'll show you what I mean. Don't type this. G is equal to input, hello, syntax error. Okay, great. I'm going to go back and fix it. It's probably not going to let me do it. Actually, it might let me do it. But anyways, you don't want to write programs into shell. Instead, you want to write and save them as a script. So pretty much anytime you launch idle, the very first thing you're going to do is hit File, New File. Once you get a blank screen, you're good. Bless you. Then the challenge becomes, how do I display half and half? So you create a new window. The first thing I always do is just do a save as and get it out of the Python directory. Do not save it into Program Files 86 Python 35-32. That may work for a while, but eventually you're going to break Python to the point where it won't even load. That's because this is a system directory that's only supposed to have Python files here. In an ideal world, it would be read-only so that we couldn't even make any changes to it. But maybe there are some good reasons why it's not read-only. So you just want to save it somewhere else. Go to your desktop or your documents directory or your flash drive or whatever. I'm going to call this one guess.py and store it in my CIT1113 directory. If you want, you can drag folders over into your favorites list here, to make them easier to find next time. That's what I did with CIT1113. I need to get rid of that 113B one. All right, so guess.py. So print. I'm just going to type in what they type. Welcome. G is equal to input. Guess the number. I'm shortening it by making a number sign. And then guess is equal to integer version of G. Convert that string to an integer. And while we're at it, I'm going to put my name up here and the date. And describe the program. All right, we've got our guess. Now we're going to check it. Now, although they don't show it, I like to put white space in my programs. That's like the breaks between paragraphs in a book. If you're reading a dense book and there are no spaces between the paragraphs and the paragraphs aren't tabbed over to give you some indication of where one begins and one ends, it's hard to read. Well, code kind of comes in paragraphs too. This chunk of code is kind of an introductory thing, and then we're getting some data, and then now we're going to process it. You don't have to do it, but I would stick a blank line there. Blank lines are completely ignored by the code. You can put, hundreds of them in. That would be very annoying, but you could. So if guess, and here we go with the equal business. Remember that if you have an if statement or a while statement, it has to have two equal signs. Everywhere else it just has one. Print. You win. And again, I just add spaces to make things easier to read. And it looks like I'm not very consistent about doing that. Else, colon, print, you lose. And then print, game over. This is a very excited program. Everything it says ends in an exclamation mark. Notice that every time you tab over, the line above it has a colon. If you start tabbing and the line above it didn't have a colon, it's probably wrong. If you have a colon and you didn't start tabbing on the next line, it's also kind of wrong. And I'm going to give you an example of incorrect tabbing. Don't follow my example here because it's wrong. But if I did that, that would be wrong. Why? It would only say game over if they lost. Now maybe that's our actual intent if later on we're going to modify it so that, they get multiple guesses. But right now it's not supposed to say game over only if they lose. But by tabbing it, we put it under the else clause. So it says game over only when we hit this else condition. So when you're typing code in, it's real easy to skip the back tabbing that you need to do when you're done with an if statement or when you're done with an else statement. And when I'm wandering around, I will probably get to point out places where your code's not working because you didn't stop tabbing at the right place. Other languages do solve this problem in a different way, and I'm going to show you what that way is, but don't type it because it doesn't work in Python. They use curly braces, and you may have seen these if you used other languages or have ever looked at code before. This is by far a more common way of doing it. I like those because they very clearly mark the begin and end of the code. It's real difficult to get this print statement in the wrong place once you see a curly mark, a curly brace there. And it doesn't matter how this stuff is tabbed. The tabs in a language that supports curly braces like Java and C, C++, C#, the tabs are optional to make things easier, not mandatory. They are mandatory in this language. I'm going to undo all the changes I just made. Alrighty, we need to test our program. Save it, and then run it. You can just click F5, or you can choose Run Module under the Run menu. And it says, guess the number. Well, I know what the number is, but I'm going to guess it wrong first. You lose. Game over. How rude. Alright, let's try it again. I tend to close the shell. Let me show you what I just did, rather than just rerun it over and over in the shell. That just gives me kind of a clean slate the next time I run it. There's nothing wrong with leaving the shell open, but if I keep doing that, if I keep running it without closing the shell, then, you know, it's eventually going to get so that the text is kind of off the screen. Just it's harder for y'all to see on the screen. So I tend to close it after every running. If the program's not done yet, it'll say, do you wish to kill it? How violent. Of course I do. Alrighty, there we go. Now I'm going to run it and give it the right answer. Run module again. Guess the number. You win. Game over. Okay, so now I'm feeling awesome. Anybody have any syntax errors that they need help with? Okay. When I make that offer, take me up on it. Don't wait until 20 minutes down the road and you didn't ever get it working. I mean, you can do what you want, but just a recommendation. Alrighty. So that is a boring game. We will need to improve it. Even before we go any further and see their recommendations, what would perhaps make this game more fun? Let's make a list. See if they cover everything that we think would make the game more fun. Fun being a relative term. This isn't gonna, you know, beat Skyrim or anything in terms of gripping, but whatever. What are some improvements we can make to the program?
You can give them a little bit of a range, number range.
Yeah, why don't we let the program pick a random number, and yours was good too. Pick a random number, tell the user the range, you know, pick a number, okay, 3,278.5. Drats, I didn't get it. You know, okay, it was only supposed to be between 1 and 10, whole numbers. Okay, and then loop. Give them multiple tries. Other ideas, maybe we could just give them a limited number of tries, or at least tell them the number of tries. Count the number of attempts. I don't recall if the textbook does this, but we will modify it. So it's kind of a sidestep. I'm going to hit the idea of doing a binary search. A binary search, not binary in the case of zeros and ones, but if we're told to guess a number between 1 and 100, this is kind of the most efficient algorithm. 50. It tells us too high. Now this program, okay, that'd be another thing to do. Count the number of attempts, tell them too high or too low. Otherwise, they just have to guess 100 times and hope they get it right. Okay, but here we can use some strategy. 50, too high. Okay, 25, too low. 37, too high. You see what we're doing is we're going by halves each time. If the range is between 1 and 100, we try to pick a number that's, you know, as close as possible to being between 1 and 100. And you know this trick. It's just you haven't seen it written out and this described as thus. Okay, once we know that that's too high, that means that the numbers 51 through 100 have been eliminated. We've reduced our number of choices by half. And so then when it says too low, we know that our numbers have to be between 26 and 49. Okay, I goofed this first one. When it said too high, it lowered the range to being between 1 and 49. So we tried to pick a number between 1 and 49, 25 being pretty much that. And then too low, 26 through 49. 37, that's halfway between 26 and 39. I may be off by 1 on these things. Now it says too high, so we know that the number is between 26 and 36. Now what's a number kind of halfway between 26 and 36?
31.
Yeah, 31 or... it's a range of 12, so 31 or 32 would do. Go with 31, that's cool. And say that was it, you know. Yay, you got it. That's called a binary search, where you keep zeroing in on it by halves. That is the most efficient algorithm for solving a guessing game. And by algorithm, I just mean a series of steps, you know. You can do this in your head. You don't have to have a printout of it, you know, or a program that tells you how to do it. We just kind of know how to do it. And there is a way of calculating the maximum number of guesses it would take if you followed this algorithm perfectly. Now, right off the bat, I kind of forget what the algorithm is. But, you know, at most it ought to take 5 or 6 or something like that, you know, guesses to get it right. We could scold them if it took them more than that or whatever, you know, and praise them. It kind of depends on the number, really, on the data, because if it really is 50, they're going to get it right on the first time. So, yeah, it's not that great a game. Okay, so that's a binary search where you keep cutting it in half. And is that super duper duper important at this point? Not really, but it's a good concept to know later on when you might be going through a list, like if you're going through a list of names, computer-wise. It's not the most efficient just to start at the first name and keep checking, you know? Because we may have 100 people in this class and we're looking for Mary. Starting at Abraham and going down is not the most efficient way. If you can determine who the middle person in the list is and then check to see if it's greater or less than, and then you can, you know, modify that to knock off half of it and then guess again, you know, halfway between the two numbers and then halfway between the two numbers, then you can get, you know, in a maximum of 5 or 6 jumps rather than potentially having to start from the beginning, you know, and going all the way to the end to find it. The worst case scenario in something like that is what if the name didn't even exist in the list? It would take you 100 checks to go from the top of a list that had 100 items to the bottom to determine that it didn't exist. Whereas if it was following the binary algorithm, you know, it would take at most 6 tries. I keep using that number. I may be off. We'll research that in a little bit. Okay, so that's our first iteration of the program. I'm just going to copy this into our notes. You don't have to. Fine with me if you do. Okay, so these are going to be our ideas for improvements. Let's see which one they go with first. I don't know why I put a space there. We've already mentioned that this editor and a great many other programming editors color code. And the reason it color codes is just to get your brain to recognize things more easily. Because if this was all black and white, it'd be harder for you to double check. You know, after a while, you get used to the fact that the words print and input and stuff like that are purple in this editor. And if you type the word print and it wasn't purple, when you were looking back at the code, you go, oh man, I have a typo there. You know, something like that. It's just a visual indicator. You can change those colors if you need to, I believe. Some people have the, you know, I know that there are 3 kinds of color blindness, and I don't remember the 3 different technical names for them, even though my father has one of those. If you need to tweak the colors, that's cool. Save and run our code. We did. They called it game.py. Test driving the program. They are running it over and over and over. Not that this is a big serious thing, but a lot of people tend to do this in the early days of programming. They run the program, and then they expect the program to still be running even if it's not, and so they take another guess. You have to program You have to write the code yourself that'll make it loop. Congratulations, it works. We've kind of talked before about the 3 steps that programs generally follow. Now sometimes they are looping over and over and over and repeating those steps infinitely, but it's gathering input, processing the data, and then generating output. Everything does that, even if it's a game. Mario gets the input from the control pad. Based on the input, the program decides, to adjust the position of everything on the screen, whether he's going to begin a leap or, run to the left or whatever. After it's updated all those objects in the screen, then the output is displayed. Or excuse me, after everything is updated in memory, the position of everything, then it displays that information to the screen in a format that, we like looking at. So the typical processing flow: input, process data, output. Now, a complex program will have a whole bunch of different places where it's doing these things. And they will jump to other parts of the code, and but you're sitting there at a start screen in a game, and then you start the game. You press the click button. That was an input and the processing data and an output. And then it goes to another point, and then it goes to another point. But ultimately, that's really because if you're not going to output anything, there's no reason to be processing the data. The input could come from keyboard. It can come from stuff that's read, off the disk. It could come from sensors that are detecting temperature. You're not typing much into your car's computers, but it certainly is responding to input. I've never heard of Python. Is it popular? Yep. Google uses it. Industrial Light and Magic uses it. YouTube uses it. NASA uses it every time you, I guess I should call it NASA, National Air, they use it every time you see, those pictures that the space probes or whatever are sending back. It's probably been processed with a Python program.
They could have used this as blackmail material, but instead they decided to put it in a book.
Yeah. So when I'm done with this book, I'll throw Python away and use something else, right? And maybe not. Python may be the only programming language you ever need, or you may never use it again, but it is a popular language. It's an actual employment skill. But a buddy of mine told me I should learn Java or C#. Both of those are great programming technologies, but they can be difficult to learn when you're just starting out. Anyway, this is a book that's designed to teach you how to program, and using your Python as your first programming language will help you do that. There seem to be many versions of it. Broadly speaking, there are 2 main versions of Python that are out there in common use now: Python 2 and Python 3. Now, Python 3 has actually been around long enough that anybody using Python 2 probably needs to have a good reason to doing it. But there's a lot of code written in Python 2, and the syntax of it is different in some ways. The simplest example is just the print statement. In Python 2, you don't put the parentheses around it, or at least you don't have to. If you do this, print, game over, that works in Python 2, and then when you try to take that code into Python 3, it doesn't work. So, people have to convert their software, and sometimes you don't want to pay programmers to do that, and so you just tell them to learn Python 2 and to keep maintaining the software. That's why there's still billions of lines of COBOL out in the world, the language invented in the 50s. That's about enough of this. Will Python run on my phone? Depends on your phone. Yeah, you can install a version of Python under iOS or Android if you really want to. Programming on with one of those little touchpad keyboards isn't my idea of, a really fun time, but I've done it when students need help and I don't have a laptop. I don't get it. How am I supposed to guess the winning number? All the program tells me is whether it's right or wrong. Come on, give me some help. So, the program should display the range. Well, the program should display whether the guess is too high or too low. We can do this by changing the code. That's the old version. Alrighty, this is kind of talky. Here's an example of what we might want it to display. Too high, you win. Too high, too low, whatever. A program is more than a list of commands. A list of commands would only run in one direction, from top to bottom, just straight across. running every single line in it, like a grocery list. Like driving straight down a road with no veering left or right, no looping. Codeville, your program is more like a network of roads. Well, when it says your program, it means the code that you normally write. There are different things that get executed only at certain times. And there may be times when you're going in a circle, asking them over and over for the right number. And if you guess it right, then you're going to veer off one way and do something. If you guess it wrong, then you're going to veer off in another. That's known as a path. A path refers to the set of instructions that the program actually follows. And it may not follow all of them. You know, if I get 5, it's going to say you win. It's not going to say you lose. So the path of the program was print that, do that, skip those, and print. Just like if you're driving through a town, you won't hit every single street. So that's known as executing a particular path. So code executes a particular path, meaning that it may not hit every instruction. In your program every time it runs. As you write more complex code, especially in real-world code, error handling takes more and more and more code in order to get your code to work right flawlessly. It may need to handle things like, running out of space on a disk drive, although that doesn't happen much anymore, or the internet being down, stuff like that. And so there is specialized code in your program in order to respond to each one of those things. And you really don't expect your program to hit every single line of code. You don't expect it to handle an error state if there wasn't an error state. So quite often, in a larger company, a team of people, you will have some people whose entire goal is just to test the program and to make sure that everything works right, even when the program gets into an error state. And that sounds like an oxymoron. It's going to work right in an error state? Yeah, because you want it to recover from that. You don't want it just to display an error and then crash back to Windows or whatever. Your program has encountered a blah, 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 and that's about the worst thing. Well, I guess there are worse things. There's famine and stuff like that. But relatively speaking, that's the worst kind of program. So our if statement, that's a branching code. If something is true, if the guess is equal to 5, then that's the true path. This is all the statements that would get executed inside that block of code that was indented under the if statement. If the if statement was false, then there's a different path of code that gets executed. All the statements that are indented under the else clause. And I know that this seems super obvious to some of y'all, but I guarantee that there's somebody here who this may be helping it click where it wasn't helping it click before. I just know that from experience. So we've already seen a branch. If and else. There's another form of branching used in other languages known as a switch and a case statement, but we're not going to hit those in Python. They're not available to us. So pretty much anytime we do some branching in our code, it's going to be based on an if statement of some kind. All right, so here's our program expressed as a roadmap. The guess is equal to 5, print you win. And then once they come back together, once we stop indenting, print game over. Guess is not equal to 5, false, print you lose. And then the code comes back together where it stops being indented and prints game over. All right. So let's see if this makes any sense. We're going to modify so that not only does it check to see if it's equal to 5, but if it's less than or if it's greater than. So that's going to require a more complicated branch. We could use what's known as a nested branch. Well, let's see how they do it. Yeah, here we go. If it's true, great, print you win. If it's false, we get to another branch. Is it greater than 5? Yeah, print true. Or no, don't print true, print your guess was too low. If it's less than 5, no, I've got that backwards. But you know what I mean. If it's greater than the right number, you print one message. If it's less than the correct number, then you print another message. All right, this is belaboring the roadmaps a little too much. We've hit these for 20 pages. All righty. So here's what their code looks like. Where it used to say, if guess is equal to 5, print you win, else print you lose, we're going to change it a little bit. Just get to the chase. I said get to the chase. Okay, here we go. If the guess is equal to 5, print you win, else, and inside this else, everything is indented. We have another branch going on here. If the guess is greater than 5, print too high, else print too low. So this is known as a nested if. It's an if that's nested inside another thing, just like an egg nests within a nest, or just like those Russian, dolls with the little, dolls inside the big dolls. This code is inside an if or an else block, so it is nested underneath it. Okay, so we're going to make that change to our code. Where it says you lose, we could delete it, we could comment it out. I'm just going to comment it out, and we're going to put another if statement. If guess is greater than 5, colon, print no. Guess is too high. I'm going to stop indenting one level, and then else colon, print, guess is too low. Very few languages have the word end if. This one doesn't. That would indicate, the stopping of that clause, which might be nice. Don't type that end if. And the reason why I say it might be nice is now we're going back two different tabs in order to get to this final statement. So you just have to kind of realize that all of this code is under that else clause. And then these are nested within those particular ones. And you have to remember the flow of logic, just like roads branching. We want this one to get executed no matter what. So it has to be completely unindented. All the roads have joined back together. All the paths have joined back together at that point. So let's test it. Guess the number. 6. Too high. Game over. Okay, the game is still kind of lame because we have to rerun it every time. Guess the number. 4. Too low. Game over. Guess the number. 5. You win. Game over. Okay, now why did I run it 3 times? Right, I wanted to make sure that every path worked. If you were giving somebody instructions to a city and you didn't double check that one of those roads was one way or that there was construction or something like that that was blocking it, then if the person following your map or your instructions drove through the city and happened to get there, they'd be ticked off at you. So when you're testing, you generally try to test every path through it. After a while, you can start trusting that one chunk of code, is valid. Meaning that if I don't change the code in that you win thing, I may not necessarily need to test that every single time. It's kind of working now. But then if I make a change to that code, I need to go back and test that again. So, test every path in your code. Typically what programmers do is they test it to make sure the code works. They don't test it to see what happens when the when the code's not going to work. That's why you have testing departments. That's why testing is actually a skill, that can be exercised, that you can get better at. Because if you only test to see if your program works, then somebody else is going to find a way to break it. So the guessing game needs to be able to run some code repeatedly. Might take them 3 guesses, or 4, or 10,000 guesses. That would be pretty sad if it took them 10,000 guesses. But if we never told them the range of numbers, Anyways, okay. Wouldn't it be dreamy if there were a way to get a piece of code to run several times? But I guess that's just a fantasy. No, that's not true. Loops. Loops let you run the same piece of code over and over again. It's like a roundabout or something like that. Answer is equal to no. Is our answer equal to no? No. Answer input is equal to, are we there yet? Then it loops back around. Is the answer still equal to no? Then we keep driving. Is the answer still equal to no? After we ask a 3rd time, we keep driving. Finally, they're going to type in, yes, we are there. We're going to be able to exit our loop. Print, yay, we're there. That's a conceptual loop. The big difference between a loop and a branch is how many times the code will execute. If we go here, this is only going to execute once if guess is equal to 5. It's not going to keep printing you win. But if this said while guess is equal to 5, then it could repeat as many times. It would keep repeating this code until guess stopped being equal to 5. So there's a difference between these two statements. You don't necessarily need to type this. I'm going to probably put this, well, why don't I just put this in the notes in the first place? If x is equal to 5 as compared to while x is equal to 5, colon, print, wow. That's only going to print it at most once. It might not print it at all. It's conditional. While x is equal to 5, print yay. If x was equal to 5, it would keep printing that forever, because nothing would ever change the value of x. That's called an infinite loop. So there would need to be some kind of exit statement, some kind of break statement, something that would cause the code to exit that loop, or something has to change the value of x. And if neither one of those things are true, if there's no way to exit the code, or if the value of x never gets changed, if your condition never evaluates to false, then it would loop forever. So watch out for infinite loops. Code repeats forever because the condition never changes. So what would we need here? We would need something in here that could change the value of x to something else. Just conceptually. This is not part of the game. But they're not going to keep guessing the same number over and over and over. Well, I guess they could. We can't stop them from doing that. So Python's loop. Answer is equal to no. While the answer is equal to no, input, are we there? If they keep typing no, this code is going to repeat over and over and over, because it's not an if statement that goes down to here when it's done. It keeps coming back and checking the condition again. This part is known as the condition. As long as that condition is true, it will keep doing that. Finally, they type in something other than no. It falls out of the loop and prints we're there. Alrighty. So we're going to change it a little bit, and it's going to involve tabbing multiple lines. And why do I say that? We're going to stick a word in here, or a line that says while guess is not equal to 5. And then we're going to tab a whole bunch of stuff over. So in a good programming editor, the way you tab multiple lines is you can highlight everything that you want tabbed, like that, and then click the tab key, and it pushes them all over. Now what if you want them to go the other way? Well, some programming editors let you hit Shift Tab and it'll go the other way. I don't think this one does that. We would have to choose Dedent Region from the Format menu. That would get it to go the other way. I love that word, dedent. I'd never seen that word until I ran this program. So anyways, that's how you indent code. You highlight all the lines that you want blipped over. So let's do that. Highlight all of this stuff up to but not including the print. Starting with the if statement but not including the game over. Click Tab. And just like I said, if you start tabbing but there's no colon in front of it, it's not correct. We need to add something here. While guess is not equal to 5. I'm not sure I did that right. The reason I'm saying that is because if they guess the number immediately, let's go see how they did it again. Yeah, if they guess the number immediately, this code doesn't tell them that. It just says game over. Oh well. We'll just ride with that. Okay, so let's see if that works. If you've got this, and everything under that except for the print statement is tabbed inside it, and there are no typos, then it should loop until the guess is correct. Guess the number. 10. Ooh, that's not good. Alrighty. You know what we're going to do. Maybe I really did look at the code wrong. These lines need to be part of the while statement. I'm going to start rewriting their code if it doesn't show this. Yeah, it does. Okay. We need to initialize this guess variable with a value that's invalid, that is not equal to 5. And we need to take these two lines of code and put them under the while statement. So highlight those two lines of code with your mouse, or I like using the keyboard, so I hit Shift and down arrow or up arrow to highlight two lines. Cut them, your favorite way of cutting them. Right click, cut. I use Control X to cut. And then paste. However you like to paste, I use Control V, as in vehicle. And then those two lines have to be tabbed as well to match the rest of the indentation level. Now this code actually is broken at this point. Let's run it and prove that. It says guess is not defined. And the reason why is we have a conditional here. We have an if or a while that's checking the value of guess, but guess doesn't have a value yet. Everything has to be defined before you can use it, you know? If you don't have a box, you can't guess what's in the box, you know? If you don't have a house, you can't paint the house red. So, we're going to initialize it. They say 0. I guess that's a good enough initialization value for it. So if you think it through, the reason we have to set this, and what would happen if I initialized it to the value of 5? How would the program run?
Stop instantly.
Yeah, it would print welcome, and then it would print game over. Because this code is conditional.
Only runs if guess does not equal 5.
Right. The body of the code, the important stuff, the guts, only gets triggered if the guess is not equal to 5. So you don't want to initialize it to something that would trigger it, or that would not let it in. So guess is equal to 0. Let's play the game for a bit. I want to play a game. Here we go. Guess the number. 10. Too high. Guess the number. 1. Too low. 5. You win. Game over. Alright, we've got a lot of code at this point. I want to make sure that there are no typos. So in this language, tabs will get you. What do I mean by that? If this looked like this, don't do this change because it breaks the code. Then what does it do? The path of code is that this code inside the while statement is all that gets repeated. It never gets to this statement until it leaves the while loop. So it's not until they get the guess correctly that we even check to see if they won or got too high or too low. So we don't want that. Alright, we've checked off a couple of these things here. things that would make the game better. Tell the user to range. Nope, we haven't told them that. But we've looped. We've told them too high or too low. Pick a random number. Random means that we can't predict it ourselves, you know, just like rolling a die. Be kind of boring if every time you rolled a die you knew in advance what the number would be, although you can make $1 million. Okay. So, they show us how to generate random numbers in this language. We have to add a couple lines here, and then everywhere there was a 5, or if you made it a different number, 11 or whatever, we're going to need to make that a variable. The reason we want it to be a variable is it's not going to be 5 every time. It could be something else each time. So we're going to make this in a sequence of changes. We're not just going to type in what they have here. Go back to your program, and we have to initialize a variable, or else when it gets to the if or the while, it'll break. Make this say secret equals 5. This is the line that we just added. And then everywhere you see a 5, change that to secret. So I just changed that. It was a 5. And the only reason I'm putting these little comments here is to make it easy for you to double check all the changes that I made. Change all of those 5s to the variable name secret. Looks like it was in 3 places. And then run it and test it, make sure it works again. So I made 4 changes. I added that line, and then everywhere the number 5 occurred, I changed it to secret. Then run it. Guess the number. 6, too high. 4, too low. 5, you win. And I know some people chose other numbers than 5. You know, just modify your instructions in your head to match. Okay, now instead of picking the same number every time, we're going to pick a random number. And so there's a statement called import, which will bring in a library. A library of code is a chunk of code that's already been written, maybe by you, maybe by somebody else, waiting for you to use, but it's not actually part of your program. So we have to bring it in to our program. And there are the name of the command that does that is different in some languages. In C++, it's called include. In this one, it's called import. So we're going to add an import statement. From random import randint. And so I'm sorry that that's kind of cryptic, but we will do that. Above the line that says secret is equal to 5, add this. From random import, and now we have to get the spelling of this right or it's not going to work. R-A-N-D, rand, I-N-T. Yeah, random integer, kind of abbreviated. And then instead of saying secret is equal to 5, so we just added this line, and we're going to change this one. These are the 2 lines that are being modified at this point. I did resume the recorder. Yep, good. Paranoid about that, based on bitter experience. Okay. Secret is equal to randint, parentheses 1 to 10. What this means is generate a random integer that starts with 1 and ends in 10. You know, that's our range. You want to make the game harder, you make it 1 to 100. You want to make the game super difficult, you make it 1 to 1 million. So, instead of secret is equal to 5, secret is equal to R-A-N-D, I-N-T, randint, starting at 1 and going up to 10. I'm going to make mine 100 just to be more fun. And then I'm going to type something into Google that doesn't really matter. Log base 2 of 100. Okay. That is the formula that tells us if you played a perfect game, it should take at most 6.6 guesses, 7 guesses, if you have a range of 100. If you had a range of 1,000, then the base 2 logarithm 2 of it, it would take at most 10 guesses. It's kind of interesting that increasing the range, multiplying the range by 10, only added a few to it. What if we were nuts and we made them do 1,000,000? Then they ought to be able to get it in a maximum of 20 tries. So back to 100, ought to take at most 7 tries. If it was 10, then if they follow our guessing algorithm perfectly, it should take no more than 4 tries. So I think 100 is a good version. Let's run it and test it. Guess the number. 50. Too high. I'm going to stop reading off numbers because you're going to be using your own. Too high. Too low. Too high. Too low. Too low. Okay. It took me 1, 2, 3, 4, 5, 6, 7 guesses. It took the actual predicted maximum number of guesses. Sometimes you'll get it right on the first try. Another reason that I close a shell when I'm done with it is quite often I think, oh, I want to run it again, and I go to shell, and the run command's not there. That's not where you run it. You go back to your code and run it. I'm double checking it to make sure that it's not the same number 2 times in a row. Conceivably it could be, but the likelihood is pretty low. Okay, yeah. All right, this is a pretty good guessing game. We have checked off several of the points that would make it good. We haven't told them the range. We need to modify that print statement. That print statement that says input parentheses quote, modify it to tell them the range. In the meantime, I'm going to add check marks to my list. Pick a random number, tell the user the range. Well, I'm going to go do that, so I'm going to go ahead and mark it off. Okay, I'm going to remove these comments here because they're making things harder to read. If your code gets too visually noisy, also this print you lose line, really don't need that anymore. Okay, now it looks cleaner. The cleaner the code, the easier it is for your brain to process when you're looking at it. Comments don't slow the program down at all. They just visually clutter it. We want our programs to display ideal feng shui. Okay, so guess a number, and then I'm going to put some parentheses before the quote, not after it. I'm going to give them a range between 1 and 100. Or maybe I'm just going to say 1 to 100, because if we say between 1 and 100, they may not think that 1 is possible if they're a programmer. I'll tell you why in a minute. Okay, there we go. 1 to 100. All right. Now, why did I say that little bit about if we say between 1 and 100? There are inclusive ranges and there are exclusive ranges. Inclusive means that 1 is part of the range, and so it's possible. Exclusive means not part of the range. Typically, the first number in a range in a computer is always inclusive. Quite often, the second number is exclusive. In many languages, if we generated a number between 1 and 100 with a statement like that in the whatever library they were using, it would actually go from 1 to 99. And it sounds weird, but that's just the way it is. And if you didn't specify a first number, it would start at 0. Just like I say, computers always start counting at 0 unless told otherwise. Okay. We're going to check for syntax errors again, and then I'm going to veer from what the book shows. We're going to count the number of tries. Not going to be too hard to do that. But before we do that, we need some kind of variable that's going to keep track of the number of guesses they've made. And I don't really want to use the word guesses, plural, because it's too similar to the word guess. I try to make my variables different. Now don't type this, but if you did this, I have the variable G1 and then another variable called GL, then somebody would come over and punch you once they figured that out. Because, you know, in some places you're changing the value of G1, and in other places you're changing the value of GL. You know, if your variable names look too similar, then it could be a problem. What's another case of that? You know, if you have NO and then you have N0, you know, O's and zeros, ones and L's are easily visually confused. Also, if you have things that differ only by whether it's plural or singular, then that can be wrong. So what's a good variable for tracking the number of guesses? What do we want to call it?
T.
Pardon me?
T.
G as in
T.
T. Yeah, for number of tries. T for tries would work. Maybe the whole word tries. Generally speaking, words are better than single letter variable names. I veer from that just because typing word, you know, takes more time and you're more likely to make mistakes. So I'm going to use the whole word tries. Tries is equal to 0. Every time we get a new number, we're going to increase the number of tries. Maybe I'm just going to put that as the first line of code underneath the while statement. So I just added this line. And heck, if I'm going to have a comment, I may as well make it a good comment. I'm going to say number of attempts. Number of attempts. And then down here, underneath the while statement, tries is equal to tries plus 1. And that's increase, or the fancy programmer term, increment. Increment number of attempts. I'm just going to leave the word increment there. Okay. Now, do we want to tell them the number of guesses while they're guessing, or do we want to wait until they win?
The latter.
I agree. Let's wait until they've won. So down here where it says you win, we're going to add another print statement. Print tries equals end quote, comma, and then our tries variable. And be careful because I capitalized it here and I made it lowercase down here. Now these later two comments are not really informative enough. I'm probably going to delete them. But just to let your eye hone in on the places that I'm changing, because I type at 100 words a minute, and I know that some of y'all only type 90 words a minute. So, in other words, it can be hard to follow along. If I ever type too fast, throw something at me, I'll slow down. Now I wish I had left it 50. I mean 1 to 10. It's taking too long to guess. You can always change that. I'm going to make it guess a number between 1 and 5. Realistically, I should also modify this thing that says guess the number. I'm going to do that as well. Okay, these are the only changes I made, and that's just to make testing easier. I want a much smaller range. Guess the number. 2. It's too low. 3, 4, 5. Okay, tries is equal to 4. Cool deal. I think we have taken this program about as far as we want to take it. The only thing that would make it any better would be if we asked them if they want to repeat. And to do that, we would have to put all of this in a loop. And I don't feel like doing that. We've already got like 3 indentation levels. We've got a while loop, and then we've got an if, and then inside the else, we have another if. And so I think the logic is getting visually complex enough. What? Alright guys, if you go to the Dropbox, this is Dropbox D. Just to stop me from being tempted to keep adding changes to our guessing game, let's go ahead and upload it. So, Dropbox, click on the D, add a file, upload, go find where you saved it. I know everybody knows how to do this. Guess. I think I called it guess, and then in the Dropbox I called it guessing. I'm not sure. Nope. Alright. You may want to add some code to these programs if you're going to be sending these to somebody else. Like, you know, you want to send to your grandparents your program. If you mailed them, first you tell them to install Python. Yeah, right. And then you run it. If you double click on the program, mine's not doing this because of the way I configured it, but if you double click on it, it'll probably go to a black screen like that. And that's great and all, but as soon as the program is done, it immediately closes the window. If you don't like that, if you don't want it to immediately close the window, then you can stick at the bottom and input, you know, press enter. Just as a final thing, you know. And that way, when you run the program by double clicking it, once you get the guess right, it says press enter. They get a chance to see the result. If you're doing those conversion programs and you close the window before they actually got to see, you know, how many pounds it equaled or whatever, they'd be annoyed. Alright, if you check contents, refresh your contents, whatever, and go to notes, PowerPoints. I didn't realize that all the PowerPoints I used last semester are already up here in a separate PowerPoints folder. So it could be that there's some duplication. Or in a previous semester anyways. Should be a document called PowerPoint 2. Go ahead and click on it, download it. Now this is actually adopted from a textbook that we're going to use in the fall. So those poor students actually have to buy a text. So back to the topic of pseudocode. We've seen examples of statements that represent pseudocode earlier in the course. So for example, if we're going to ask for the number, we're going to multiply that number by 2 and then we're going to output it. Here is the textbook perfect version of pseudocode. Start, stop. That marks the pseudocode. Input my number. Set my answer equal to my number times 2. Output my answer. Now when I was walking around helping people, I told them they could leave off the word set. That's okay with me if you leave off the word set. If I didn't correct you and you haven't uploaded it, go ahead and add the start and the stop. So using pseudocode involves writing down all the steps that you use in a program. Pseudocode is flexible. It's a planning tool, not the final product. So instead of start and stop, some people use begin and end. So instead of writing input my number, some people write get my number or read my number. So instead of set my answer equals my number times 2, some people write calculate or compute. or leave off the word set entirely. Instead of writing output my answer, some people do display or print or write. Whatever. I'm probably going to follow this convention pretty closely. The input my number is going to be the words. I'll probably leave off the word set. I'll either vary between using output or print. Either one of them would work. And the thing is that each language has a different way of doing this stuff. So if you're going to use C# and you're going to write your answer out, you use console.write. And then if you use another language, it's going to be another syntax entirely. So when you're doing pseudocode, you don't end statements with punctuation. Well, we don't in this language either, except for the if statements and the while statements, but some languages require semicolons at the end. We don't do that in pseudocode. It wants us to do program statements with lowercase letters. I don't care if you're doing it in Word. Word capitalizes sentences. I don't care if they're uppercased. Each program statement appears on a single line. If that's not possible because the line is too long, then you kind of break it up into two lines, but you indent the secondary line. Every program statement performs one action: input, processing, or output. In coding, sometimes you can chain these things together. I'm going to give you an example of that. No, I'm not. Yeah, I am. This would be an example of a programmer who thinks they're too clever by half. We could do this. X is equal to input, enter a number. Y is equal to X times 2. Print the number doubled is, comma, Y. That'd be a good way of writing it. That's pretty clear. Or you could do this. Print the number doubled is the integer version. Yeah, I've already messed up because I had to convert that input to an int. So X is equal to int X. Okay. The integer version of input, enter a number, times 2. It's already gone off the screen. It's too long. You could do all four of these lines in one line of code. Do you want to do that? Not really. Our goal is not to write the fewest lines of code possible. Some places, stupid places, measure your productivity in the number of lines of code you write. That's kind of bad because your goal in programming is also not to write the most lines of code. It's to write, a happy medium where the number of lines of code is exactly enough to solve the problem while being readable. This is not nearly as readable as this sequentially. That's just an example. But what this is doing is it's using the return value from one function as an argument for another one. See this one? Returns something, stores it there, which is then fed into that. You could take that and put it directly in there, like that. Similarly, you could take that and paste it right into there, and then multiply it by 2, so we got the answer. I've still goofed. Anyways, see, that's the problem. If you're trying to stick too much into, one line of code, it's hard to read, hard to debug. That's why in the document here, wrong one, closing that one, strongly suggests each statement performs one action. So then a flowchart. In a flowchart, the tilted rectangles are for input and output. The calculations, the sets, are done in rectangles. So input my number, tilted rectangle, quadrilateral. I'll probably start using the word quadrilateral, even though, as I've mentioned, rectangles are also quadrilaterals. Set my answer is math, so it goes in that. And then output is another form, so it also goes in a data block. Tilted rectangle. Some software programs that do flowcharts, such as Visual Logic, use a left slanting parallelogram to represent output. So one way is input, one way is output. We don't care. As long as you put it in a tilted rectangle, regardless of whether it's a print or an input, it's all good. To show the correct sequence of these statements, you use arrows or flow lines to connect them. Start, input my number, set my answer equal to my number times 2, output my answer, like that. Similarly, start, input my number, set my answer. You know, this is the pseudocode version and this is the flowchart version. The start goes in its own little pill shape, so is the stop. These are technically known as terminals. So, quick reference, flowchart symbols. Terminal is the oval, that's the start and the stop. A decision is either an if or a while, or later on a for. Those go in diamonds. Flow lines, input output are done in the tilted quadrilaterals. Process is done in rectangles, and then there's something called an external module call, or an external function call. This is when you write your own function. And we don't use this one, the one with the bar above it. Looping, we don't need to do looping. What we need to do is to get into flowcharting. So uno momento. It says to log into Lucidchart, once you have made an account, follow this link. After you have made an account, no longer follow this link. This is for registering a new account, actually, although it doesn't look like it. No way. Ah, for Pete's sake, I got the wrong one again. If you can try using Firefox, but it may malfunction, and if it does, switch to Chrome. If you like IE, go ahead and give it a shot. But if it doesn't work, switch to Chrome. We had a lot of problems with people using Firefox. Okay, so don't follow that link. That's the link to log in. I am now posting the link to register. The stuff in the blue text shows the link that you follow to register. It says Lucidchart, but then it's got my name after it. And the reason why is that that adds it to our Rose account. If you don't do that, you'll have a very limited number of flowcharts you can make, and you might not be able to save them or whatever. So go to Course Home, look for the blue note, click on that, and you're going to create an account. So put in your name, your Rose email, and do me a favor, for your name, also put Summer 2017. So Joe Jackson, Summer 2017. And then put your email, joe-jackson@raider.rose.edu. Obviously, you're not going to use Joe Jackson. And then make up a password. Probably easiest if you just use the same password you use for D2L or to log into the systems. And then click Sign Up. Not sure what would happen if you chose Google. I haven't tried that before, so let's just do it this way. Alrighty, we want to tailor your experience to Lucidchart. I guess we're in education. I guess we're students. Okay, give me a break. And then click Home or Personal. Alright, hopefully once you do that, you get presented with a white screen. And if later on you forget your password, I can reset it for you. If later on you forget your email address, as long as it's got your name in it, I might be able to fetch it for you.
I tried doing it because I didn't know that you had to pay for it.
Like Lucidchart, there are other flowcharting programs. It's available for, it'll work anything that has a, Mac, Windows, Linux, whatever. I wouldn't try using it on a tablet unless you have a cool tablet with a, the Microsoft Surface or whatever, something that supports mouse input. So let's create our first document. Plus document. Flowchart templates. Blank diagram. Preparing your new lucid chart. Okay, getting started. You could look at these. I guess we may as well. Drag and drop shapes to get started. And then click Next. Use the red dots to hook things up. They don't look okay. Add colors and styles to your diagrams. I use colors for a very specific purpose. You can, crayon your flowcharts if you want. Find more shapes to draw other diagrams. Okay, we're not going to be using hearts. Share your diagrams with others. Meh. You're just going to save them and upload them to the Dropbox. Can't find something? Search. Okay, please be done. Finish. Okay, so here we go. All of our flowcharts are going to start. Oh, neat. Okay, there. What it was doing in Firefox is when you hovered over it and you drag something out, half of the letters would be red, would be little black boxes. So it wouldn't say predefined process, it'd say parcel, with square blocks for some of the letters. If you're seeing that, switch over to another browser, and I'm sure that Chrome works. So grab Terminator. He'll be back. Here we go. And let's do start. An easy way to draw the next shape, and you don't have to do it this way, is if you click on the red dot and drag an arrow, it offers a little palette of other shapes. Quite often I forget to do that, and so I just grab a shape. Drag it out under here. So input meters. We're doing a flow chart for converting meters to inches. Now we need to hook those things up. So as we move our mouse over, we see a red dot appear. We just drag a line from one to the other. That's the flow line. After we get our input, we need to do some processing. So we could use a regular rectangle, otherwise known as a process block. And I'm zoomed way the heck in just so that y'all can see it. Yours won't look like that. So here we go. Drag another line. The process block, the formula for converting from meters to inches is something like this. Inches is equal to meters times 100 divided by 2.54. I believe that's the correct equation. I've only had a couple of people text me and ask me for help on the conversions. Whenever I say you can ask me for help on them, I absolutely mean it. Some people get a kick out of using their Google foo. Some people just want to, get on to the next thing in life. You can resize your blocks like that if you couldn't get it all on one line and you really wanted it to be. Also, you can force carriage returns. And what I mean by that, what if I wanted the words inches equal on one line and then meters on the other? Hit Control Enter. Right there. It'll break it into two lines. We've got our input. We've converted it to inches. What's the next thing we want to do? This being a really simple program, like your pseudocode assignment. We want to display. So, yeah, so let's use another data block for our output. Output inches. After we've output the inches, we need a stop. So if you haven't done the meters to inches pseudocode, This is pretty much the answer. Start, tab it over. Input meters, inches is equal to whatever. Output inches, stop tabbing, stop. Now we're not going to do the others, but you know, there we go. We have all these tools up here. If you need to change the text size, you can. I'm just going to highlight everything with Control A. Control A does the select all. And I'm going to make the font larger. You don't need to do this. Just showing you. Really? Not now.
The same thing.
Yeah. Okay. If you want to color them all, you can do that. I don't color them except for very specific circumstances, which we will mention later on in the semester. There are also these themes that are built in. Now I can't find them. They changed it. Well, forget the themes. They used to be right there. You'd click on it and you could change a theme and it would give you different text, different colors. The lines would be swoopy rather than direct angles.
No, on the right. The very right bar with the page, the like drop on it.
I'm ignorant. I can't find it.
Very right bar.
Theme. Okay, cool. Thank you. Yeah. Ooh, pretty.
Blueprints.
Yeah, if you want to waste all the ink on your printer, use that one. Whatever. Okay. That's all just frippery and nonsense. Okay, so we've done our first flowchart. If you were going to upload this, as I would ask you, I would want your name on it. So drag out one more block or drag out a brace. Either one works. And just put your name, the date, and you could put a program description, but that's really enough. Okay. I should have put that in a block. That looks pretty stupid. The braces are actually better used to describe certain parts of the program. Like I could put a brace here and describe what that block is doing. So now I wish I'd put it in a block rather than a brace. All right. Now let's do a flowchart with an if statement. So we're going to scroll down, or you could scroll to the left. Just find yourself some new space on it. Do a start. Let's get some input. Guess is equal to input. Or input guess. Let's keep it in pseudocode. Now we're going to use a if. And I wish I had pushed it over further from the edge of the screen. What do I mean by that? Because I'm going to have lines coming off both sides of this decision block. So I'm just going to grab all three of those by clicking and dragging to create a rectangle and pushing this over. I have forgotten to draw lines between things. You get counted off for forgetting, so I better do it too. I'm not a jerk about it. You'll get majority credit even if you've missed a line, you know. Okay, so the decision block is our if statement. If guesses equal to 5, and then the first line you print is a true, a yes. This is what happens if it actually happens. Print or output, you guessed it. Now that looks kind of lazy, kind of bad, so I'm going to use Control Enter in the middle of my text to try to make it fit better. But if we didn't get it right, this is the code that gets executed under the else. Now, people wish that there was an else block. They'll drop a block and put the word else in it. but there really is no else block. Don't know why. I guess it's because flowcharting was invented before programming languages. And so if they got it wrong, on the no line, we're going to say print wrong, you lose. You are a loser. We could be really rude. Alrighty. Now we're not done with this because we don't have a stop. Whenever you have an if statement, you need to bring the lines back together. The easiest way to bring them back together is just to grab a circle. I tend to remove the little A from the middle of the circle, and I also tend to shrink it down. You don't have to. And then make these guys hook back to it. Like that. Now that's not a command either. It's just where the paths hook back up. It's where everything stops tabbing. And our original program said something like finished or something like that. I don't remember the very last statement in our code. Go look. Game over. Okay. Don't know why I didn't remember that. That's a print, so what shape is that going to go in?
Quadrilateral.
Yeah, the quadrilateral, the data block. So print, quote, game over. I'm zooming in and out with the control key and the mouse wheel if you want to do the same thing. And then lastly, a stop. So we need a terminal. Now if we had an hour and a half, 2 hours, it wouldn't take that long, I would have us flowchart the guessing game. But it's a considerably more complicated flowchart. Alright, they've considerably changed the interface since I used it a month ago. There used to be a way to minimize this toolbar up at the top to give yourself a little bit extra space. Does anybody see? Well, that minimizes it a little bit too much, but okay. I use that thing to go to full screen. Good enough. Now I'm annoyed because I can't get to the scroll bar. Well, I can always use my mouse, huh? Alright, that's our flowchart for the first version of the guessing game. If we were going to keep going and make it look more like, I would actually just draw it again rather than just modifying this one most likely. There'd be some code up here for calculating, a random number. We might just put that in a block that said, secret is equal to random, something like that. Then we're going to need a while loop. A while looks like an if, same shape, but instead of saying if guess is equal to 5, it would say while. And while loops always loop back to themselves. So they don't meet at a circle underneath. They have some code, they have some code, they have some code, and then there's a line that comes back to the diamond. So just kind of remember, if you have an if statement, it doesn't loop back to itself, but if you have a while, it does. Now there's way more ways of drawing flowcharts than just one, especially where it comes to while loops. Some people leave the word if off. They just do that. I like seeing the word if there. So I will leave the word if on there. My flowcharts never have a line that goes back up to here. I guess I'd need to draw a while loop to show you these differences. You don't necessarily need to draw this but you could. All right, say we had a start and we had some decision to make. And then after that decision was made, we had some code that got executed. Maybe there were... What a lot of books show is a line coming back up here like that. I don't like it doing that. That kind of makes some implications that we don't really get to do. And I'll show you what that implication is. Say we got some input here. Oh man, this is getting all messed up. How's that for lame? Why am I taking all this time of illustrating the wrong way to do it? I don't know. It's just because you're going to see this over and over. If you had something like that look like this, input X, and then it had a decision based on that, and then you drew a line from here, well, not from there, from here up to here, that looks like good code, but you can't code it that way. You can easily draw things in flowcharts that are incredibly difficult to code. So I try to teach you very specific structures, very specific mental algorithms to follow when you're drawing these things, so that when you try to turn them from code into pseudocode or into Python, you actually can. There's other problems with this flowchart, is that the decision block doesn't have a no on it. There's got to be some way, for it to bail out or whatever. All right. Now that's a flowchart, but it's a bad one. What I tend to do is to make the process block loop straight back there, because that's the way the code works. You have a while, and then you have some stuff that's indented, and then you have the stop of the indented. And if you look at it and it doesn't look like the code would work, maybe this input statement needs to be inside the while block, you get a good visual clue. Oh, my input really needed to be over there. So let's save our document. I'm so likely to recommend Lucidchart to a friend. Oh, come on. There. Alrighty. I guess it's because I created a new account and it's asking me all this information again. When you're ready to save this stuff, the first thing you need to do is just to save it to your account. So do a save as and give it a name. My first flowchart. We could have given it a more serious name than that. And then do download as. So under the file menu, download as. PDFs are great. If you want to upload it into a web page, post it on Facebook because you're so proud of your flowchart, you'd probably download it as a PNG or JPEG. But y'all probably know the difference between PNGs and JPEGs. JPEGs are compressed, so you lose a little bit of the quality in order to get a smaller image size. PNGs are not compressed, so they make larger document sizes, but they're exactly what it was on the screen to begin with. And why does that matter? Have you ever seen, those memes that have been saved to disk and then re-uploaded and saved to disk, and they have all these, kind of blurry bits around the side and stuff like that? That's because they've been saved as JPEGs over and over and over, and the compression algorithm is goofing up. Whereas if they had been saved as PNGs each time, they would look the same every single time you saved it. But PDFs are good for us. So click Format PDF, Download. It would be nice if it asked you where it was going to download, but instead it just goes to your default downloads directory. Which, if you're using Chrome, you can then do Show in Folder. There it is. And if you double click it, it should launch your PDF viewer. Just to look at it. It's, Or the PDF viewer won't work, like it didn't on mine. Okay, it's just slow. It's really slow. Okay, there's my PDF. Yay, it's pretty. Convert it to a Word document. Neat. I did not know that our PDF viewers, our Foxit Reader PDF viewers did that. Convert to Word. Used to annoy me that they had this custom PDF viewer installed on these things. Now all of a sudden I like them. Okay, I'm going to close my PDF viewer. I want to upload that flowchart. So I'm going to make another Dropbox for our first flowchart. Add file, upload. Since I copied it to my 113 directory, it ought to be there. My first flowchart. Add. Submit. As long as you see confirmation email sent successfully, you got it. Here's what it looks like, the while loop. Obviously, that's not a real program. It doesn't explain what the decision is. It doesn't explain what the process is. If you ever fall behind while I'm typing, you can ask for a printout of where I currently am. Of course, you're still going to be kind of behind, and I'll try to slow down to match. But sometimes it's hard to type along, especially if you're in the last row. I'm really impressed with y'all, not even using binoculars. I'm guessing that our printer is not on. Sorry about that. Okay, guys. For our homework, I can't assign you a really complex flowchart because we haven't done much in the flowchart. And I said that your next assignment was going to be to convert the Python code, or the pseudocode into Python code. I'm actually going to make it this. We're going to draw flowcharts based on the conversions from the previous one. And so it'll probably only take you like 10 minutes to draw the flowcharts, if that. We already did one of them. We did the meters to inches. Hey, what do you know? Printed. So if we go back and we look at our prior homework assignment, pseudocode for conversions. It's just going to be draw flowcharts instead. I'll create that in a minute. All right, let's go polish off Chapter 1 of our textbook, How to Think Like a Computer Scientist, and then we'll be done. Okay. What is a program? We've talked about a program. It's a sequence of instructions that tell the machine what to do. And the commands all generally fall into a certain sequence. You have commands for input, you have commands for calculation, you have commands for conditional execution. Those are the if statements or the while statements. You have repetition. Repetition is the while. And then you have output. Whether it's sending something to a speaker or printing on the screen or whatever. I believe we talked about syntax errors. I'm not sure that we hit the way that they're being described here. So I'm going to hit them again. 3 types of errors that you have to debug. Syntax errors. What's an example of a syntax error?
Typo.
Yeah, those are typos mostly. Typos, misspelled words, punctuation in the wrong place, missing, quotes or parentheses or whatever. Then there are runtime errors. And then there are semantic errors, also known as logic errors. A runtime error is when the program crashes halfway through, not because of a syntax error, but just because it gets into a state that it can't recover from. Disk full, file not found, that kind of stuff. Divide by zero. Divide by zero is a runtime error quite often. And y'all have probably all seen these little memes. Yeah, never divide by zero. Okay, there's some bad words here. Sorry about that. Anyways, for the last time, stop dividing by zero. Okay, anyways. In programming terms, or you may know that mathematically, if you take an integer and you divide it by zero, what does that mean? You're taking 1 pi and you're dividing it to give to 0 people. And some people have decided that any number divided by 0 is equal to infinity. But, the computer can't calculate that. So it often will generate a runtime error. We could prove that by going back into idle, launching the shell, and just saying 1 divided by 0. Division by 0. It'll usually cause your program to crash unless you accommodate it. The way you accommodate it is, one, you either check to see if the variable you're dividing by is equal to 0, and if it is, you give a warning, or you surround the code by some other code that is called some exception handling. And we're not going to be doing that in this class. If you go on to take scripting or Java or C++, something like that, you will. So syntax errors, runtime errors, and semantic errors. Semantic errors, logic errors, are when the program works, it doesn't display any error messages, but it does the wrong thing. You press right on your joystick, but Pac-Man runs to the left instead. The sensor shows that it's 100 degrees outside, and so it says that it's freezing. That logic errors. It did the wrong thing. Programs do what you say rather than do what you mean. And so people have come up with the acronym DWIM. They wish that programs would do what I mean, but instead they do what you say. So logic errors are always your fault, unfortunately. Or they're the fault of the person who gave you the specifications. If somebody hands you a flow chart and you implement it perfectly, and then it gives the wrong answer, well, it's really the person who did the flow chart's fault, but then you get blamed for it. Experimental debugging. Experimental debugging is, when you keep making little changes to your code in order to figure out what's wrong with it. For some people, programming and debugging are the same thing. The process of programming is a process of gradually debugging a program until it does what you want. You start with a program that does something, and then you keep making small modifications to it. For example, if I'd asked you to implement a guessing game and I'd given you all of those improvements right away from at the beginning, and then I said the program should ask for a number, and if I gave you a big set of requirements like that, and then you just sat down and you tried to code it from top to bottom, that's difficult. Can be difficult. Some people can whip out code, 100 lines a minute or whatever. Instead, you start with something small, which is what we did. We get a guess, we check to see is equal to 5, and we kept making changes to it. The program got bigger and bigger and bigger, but we did it gradually. We were debugging it to make sure that it worked every time. Now, thankfully, there weren't any serious errors in our logic. I think I caught the one where we were asking for input above the while loop. That would have been a logic error. So the idea, Linux is an operating system that contains millions of lines of code, but it started out as a simple program. that Linus Torvalds used to explore the 386 chip. One of the very first programs he did was something that would change the letters AAAA on the screen to BBBB. And he was writing this, at operating system level rather than, loading up DOS or whatever and, having it, have a print statement. And eventually it evolved into Linux. Incredibly important open source version of the Unix operating system. Okay, scroll. This is stuff that I want you to read, but I'm not going to lecture about it. And if I don't lecture about it, it means I'm probably not going to ask you on an exam about it. But still, I want you to read it. Why? It's just kind of the patchwork, the background for this stuff. We know what comments are. Comments describe the program. The computer ignores them. They're just for us. Professional programmers do comment their code. I hate it when I can't come up with names on the fly. The guy who invented, the Doom graphics library and then the Quake graphics library and then made $1 gazillion licensing the Quake graphics engine to everybody else. You can be absolutely sure he very well documented his code. Carmack.
Or was he systems program?
He was that may be it. I think he was the game designer.
I'm sure everyone who worked on Doom made about $1 gazillion.
Right. No, you're correct. It's John Carmack. So anyways, extremely wealthy dude because he invented a graphics library for his own game, but then he licensed it to other games. And in order to keep updated, he had to make continuous improvements to it in order for it to remain competitive. And he had to hire a team of people to do it. And if there weren't comments in the code, both to remind himself of what each part of the program did, as well as to help the newbies, who were hired, you would not be able to understand it. When you're looking at a code base that's thousands upon thousands of lines long, and there's no comments in it, that's pretty much when you want to quit your job. You hate it. Or if you're getting paid to comment it, great. You just sit there with your earphones on. Anyways, very difficult to understand uncommented code. So professional programmers do comment their code. Our programs are so simple that you really understand them pretty much without adding comments. I will try to put comments in the code occasionally in order to, just trigger the idea that we should. Your comments, pretty much you should describe what the variables are when you declare them, unless it's absolutely trivial what it is. Number of guesses. If you chose that as your variable name, that probably would be, self-documenting. You wouldn't need to put $, this variable contains the number of guesses. That's a little bit too much. But, if statements. Yeah. While loops. Describe what the purpose of that chunk of code is. All right, we're already just about done. Glossary. The set of steps for solving a problem. It's a recipe. It's a series of steps. It's not code. It can be implemented in any code. A bug, an error in the program. Did I ever show y'all the first bug? There we go. Okay, first actual case of bug. All right, that implies that the term existed before that. Engineers were using the term bugs even before computers were. But, back when computers had, vacuum tubes and mechanical relays and stuff like that, yeah, if a cricket crawled into your computer, it really could short it out or cause it to crash. So, Grace Hopper, an incredibly important computer scientist, in the 40s and the 50s and onward. She became an admiral in the Navy and leading, computer projects. Found this and put it in her notebook as the first bug. A bug is just a problem to be solved. A bug is not a mistake in the requirements, and users will sometimes try to pin the blame on you when it's not your fault. Of course, you still have to fix it, but they say the program's got bugs. Okay, what's the bug? I press right and Pac-Man goes to the left. And then you show in the flow chart they actually told you that they wanted Pac-Man to go to right when you press to the left. You go, no, I implemented it correctly. The problem was in the specifications, but I'll go ahead and fix it. Yeah, and I'll charge you more money for it. So comments, we know what comments are. Information that's meant for the human to read. Debugging is the process, the art, the skill of finding and removing any of the 3 kinds of programming errors. A high-level language is one that looks kind of like English. If statements, while statements, things like that. There are lower level languages. Did I do the lecture on assembly language? Okay. That's a low level language. And then even lower than that is machine language, which is pure numbers. There's something called interpreter. The interpreter is the engine. It's the program that executes your Python scripts or expressions. When I launch the Python shell and I type 5 divided by 2 and it does something, Python has an interpreter because it has to turn your stuff, your language, into machine language. And it does that, at runtime. There's two different kinds of programming essentially. There's compiling and there's interpreting. Compiling is when you, the programmer, make an executable, an exe file or an app, that's downloaded to a phone or whatever. You don't give them the source code. Interpreted programs, you do give them the source code. If we wanted our guessing game, we'd send them out the source code. There is no app for our guessing game. There's no executable. So that's the difference between compiling and interpreting. Compiling is turning program into machine code and then giving somebody else that machine code. Interpreting is when it's done during runtime, meaning that you run the program and it's done on the fly. So interpreting, I'll sometimes say if this code compiles, but in this actual environment we're using, we mean does the code get interpreted. But compiles is such a handy term. That means that the language, the ifs and the whiles and all that gets successfully checked for syntax errors and actually executes. Portability. That's the property of a program to be able to run on more than one kind of computer. If you wrote an assembly language for the 386 chip, you couldn't then turn around and run that same software on a Motorola chip. However, high-level languages are much more likely to be portable. If they depend upon libraries that aren't available for the other system, then they probably won't work. Like, if you write a Windows program in C++, C++ is a portable language. It'll run on Mac and Linux as well as on Windows. However, it's relying on the Windows library, so it's going to be trying to make system calls that won't work on your Mac or on your Linux. But you can get emulator software that will, let you run your Windows programs on the Mac or Linux. Wine is a Linux version of it, I believe. Print functions. We know what a print function is. It displays something on the screen. A program is a sequence of instructions. It's the embodiment of an algorithm. Python shell, that's when you launch idle and you see that thing with the prompt, arrow, arrow, arrow. You can type commands directly into the shell. Most of our programming involves creating a script, a py file, and then letting Python run them all at once rather than using a shell. We know what a runtime error is. The program has started to execute. It hits a state where the program cannot continue. Can't open the file not found, that kind of thing. A semantic error, a logic error. The program did exactly what you wanted, but it was the wrong thing. Source code. The source code is that stuff you've been typing in. It's your program. That's the program before it has been compiled. After it has been compiled, it could be distributed as an exe or an app. We're not using a language that supports that. Syntax. Syntax is the structure, the grammar of the program. Every language has a little bit different syntax. And a syntax error is when we mess it up. All right, guys, we're done. Are there any questions? I guess not. All righty. Very cool. I'll see y'all on Wednesday.